Good day, math learners. I am Mr. Donald Balulan, and this time we will be discussing on the rational functions. As you can see on the concept map of rational functions, we are going to focus first on the rational expression, polynomials, and rational equation. These are the objectives for these lessons. First, recall the concepts of polynomials and rational expressions. Simplify rational expressions involving operations and answer more exercises involving rational expressions. So, let's have a review on the concepts of polynomials, rational expressions, and its operations. And I hope that you will take note some important things for these topics. So we will discuss first on polynomials. When we say polynomial, it is an algebraic expression where the exponent of the variable is a non-negative integer or positive whole number and zero. There are no variables in the denominator and under the radical sign, which will not result to a polynomial when simplified. These are the examples of polynomials. We have 2x, 3xy, and negative 5, also known as monomial because the given expressions indicate one term only. We have also 3x plus xy and 5x plus 2, also known as binomial because the given expressions indicate two terms. Why two terms? It is because the plus sign is there, which is an indicator of knowing the number of terms in a polynomial. In 3x plus xy, 3x is our first term, xy is our second term. The same thing also in 5x plus 2. 5x is our first term and 2 is the second term. That makes it a binomial. We have also 2x y squared plus 5x minus 5. It is also called as polynomial and also known as a trinomial because it indicates three terms there. So 2xy squared is the first term, 5x is the second term, and negative 5 is the last term. That makes it a trinomial. How about 4x raised to negative 2? Is this a polynomial? Okay, this is not a polynomial because according to the definition of the polynomials, the exponent of the variable is a non-integer. In the given expression, x has an exponent of negative 2. That makes it not a polynomial. How about 5x squared plus 2 over x? Okay, this is also not a polynomial because there must be no variables in the denominator. As you can see there, in the second term, then the denominator is a variable that makes it not a polynomial. Okay, this time, let's identify if the following algebraic expressions are polynomials or not. For number 1, is this a polynomial? Yes, this is a polynomial and we call this one as monomial. For number 2, is this polynomial? Yes, this is a polynomial, also known as a binomial because there is a plus sign that indicates the separator of the two terms, which are 3x and 3. Is this a polynomial? Yes, this is a polynomial, also known as a trinomial. Is this polynomial? Yes, because even if the variable is under radical sign, its simplest form would become a polynomial. If we get its result, the answer is 2x because the square root of 4 is 2 and the square root of x squared is x. That is a polynomial. Is this a polynomial? No, this is not a polynomial because 2 square root of x is already a simplest form and no variable should be under radical sign. Is this a polynomial? No, because the exponent of y is a negative number, and according to the definition of a polynomial, the exponent of our variable should be a non-negative integer. Is this a polynomial? No, of course, it is not a polynomial because the exponent of a variable is in a fraction form and it should be a positive whole number. Is this a polynomial? Yes, this is a polynomial because the exponent of the variable here is a whole number, which is 1, even if the exponent of the constant is a fraction form. So meaning, we will consider the exponent of the variable and not the constant as to identify a polynomial. Is this a polynomial? Yes, this is a polynomial. Is this a polynomial? No, this is not a polynomial because according to the definition, there must be no variable in the denominator. In this example, the second term is in fraction form and x is a denominator. Okay, and that's how you're going to identify a polynomial. So this time, we will proceed to rational expression. When we were in grade 8 and 9, your math teachers discussed this one, so let us have a review on this. When can we say that an algebraic expression is a rational expression? A rational expression is an expression that can be expressed as the quotient of 2 polynomials p and q. When we say quotient, it is the result of the division process. And if the expressions are in that process, then we can write it in a fraction form. And in a fraction form, we will deal with numerator and denominator. So the numerator and denominator here should be both polynomials where the polynomial in the denominator is not 0. It is defined as p over q where q is not equal to 0. And these are the examples of rational expressions. We have 5 over a, 4x minus 4 over x minus 1, x squared minus 16 over x minus 4, a plus 1 over 2, and 3a plus 2 over 5a. So let's have a drill. Determine if the given algebraic expression is a rational expression. For number 1, we have 4x plus 4 over 4. Is this a rational expression? Okay, yes, it is a rational expression because both numerator and denominator are polynomials. For number 2, is this a rational expression? Okay, no, this is not a rational expression because the numerator has a variable which has a negative exponent, that is x raised to negative 2, and that makes it not a polynomial. If the numerator is not a polynomial, then the given expression is not a rational expression. For number 3, is this a rational expression? Okay, yes, this is a rational expression even if the denominator is radical, but its simplest form becomes a polynomial because square root of 16x squared is 4x. Then this one is considered as a rational expression. Is this a rational expression? Okay, this is not a rational expression because its numerator says that it is not a polynomial. 1 over x is not a polynomial. What makes this one not a polynomial? Because its fraction form has a denominator of x. That makes it not a polynomial. Therefore, the given expression is not a rational expression. Is this a rational expression? Okay, this is a rational expression. Even if the numerator of the given is in a fraction form, which is 1/2 x, but its denominator doesn't have a variable. So the given expression, both numerator 1/2 x and denominator x plus 2 are polynomials. Therefore, it is a rational expression. And that's how you're going to identify the rational expression. So this time, we will proceed on the operations of rational expressions. First, let us focus on the addition and subtraction of rational expressions. So here are the steps in adding or subtracting of algebraic expressions with the same denominator. First, add or subtract the numerators. Second, place the result over the common denominator. And third, simplify the result if necessary. For example number 1, we have x over 5 plus 4x over 5. Since the two rational expressions are having the same denominator, then place the result over the common denominator. And we can write like this. So we have x plus 4x over 5. Simplify them further. X plus 4x, then answer is 5x. Then copy over 5. Then simplify further and you will get x as our final answer. Now, for number 2, the same process. We have 3x over x plus 2 minus x minus 4 over x plus 2. Since the two rational expressions here are having the same denominator, then place the result over the common denominator. So we can write like this as well. 3x minus the quantity of x minus 4 over x plus 2. There is a rule for subtraction of polynomials that we can change the sign of our subtrahend to its opposite if it is in a subtraction process. So it will become 3x minus x plus 4 over x plus 2. Now simplify them further and you will get 2x plus 4 over x plus 2. As you can see, 2x plus 4 does have common factors to each term. So factor it out and it will become 2 times the quantity of x plus 2 over x plus 2. Then cancel them out because they are the same and the answer will become 2. For number 3, the same process. We have 7 over x plus 3 plus x minus 5 over x plus 3. And place the result over the common denominator. Then we can write this one like this. 7 plus x minus 5 over x plus 3. Or you can simply arrange them accordingly and it will become x minus 5 plus 7 over x plus 3. Simplify them further and that will become x plus 2 over x plus 3. As you can see, there's no factors which are common to both numerator and denominator. So we consider this one as our final answer. So let's now proceed to adding and subtracting of algebraic expressions with different denominators. First step is to find the LCD of the rational expressions. Second, write all the rational expressions with the LCD. Third, add or subtract the numerators and retain the denominator. And fourth, simplify the result if possible. Please take note, math learners. To get the LCD, factor each denominator into the product of its lowest terms and express any repeating factors as powers. List all the different factors that appear for each denominator. If a factor is common for any of the denominators, only list that factor to the highest power that it appears. And the product of the factors listed in step 2 will be the LCD. For example, Find the LCD of negative 3 over 4x plus 5 over x plus 7 over 6x squared. According to the first step in finding the LCD of the rational expression is to factor each denominator into the product of its lowest terms and express any repeating factors as powers. So consider the denominators 4x, x, and 6x squared. The factors of 4x are 2, 2, and x, or it can be written as 2 squared times x because the repeating factors should be expressed as powers. The factors of x are 1 and x, or it can be written as x. The factors of 6x squared are 2, 3, and copy x squared, or it can be written as 2 times 3 times x squared. According to the second rule, list all the different factors that appear for each denominator. If a factor is common for any of the denominators, only list that factor to the highest power that it appears. Meaning to say, we are going to consider the factors which are common. For example, so 2 squared and 2, they are the common factors. But 2 squared has the highest exponent than 2. So we are going to choose 2 squared instead of 2. Next, we are going to choose as well 3 because we will consider all different factors even if 3 doesn't have common factors in the list. And choose also x squared because it has the highest exponent among its common factors, which are x and x here in the list. So we will list all the different highlighted factors. So we have 2 squared times 3 times x squared. Simplify them further and you will get 12x squared. And according to the third rule of getting the LCD, the product of the factors listed in step 2 will be the LCD. Therefore, the LCD is 12x squared. For example number 2, find the LCD of 1 over 5 and 2 over y. So, consider the denominators 5 and y. Get the factors of 5 which are 1 and 5. Factors of y which are 1 and y. As you can see, there are no factors which are common in the list. But we have to choose all different factors in the list to get the LCD. 5 and y should be highlighted. Get the product of 5 and y, which is 5y, and the LCD is 5y. For example number 3, find the LCD of 5 over x and 7y over x plus 3. Consider the denominators x and x plus 3. The factors of x are 1 times x, and the factors of x plus 3 are 1 and x plus 3. As you can see, there are no factors which are common in the list except 1. Just like in example number 2. If that happens, highlight right away the denominators. Now, if one of the factors are in 2 terms just like x plus 3, then do not get their product to combine, but instead just write the 2 factors accordingly. And the LCD is x times the quantity of x plus 3. Example number 4. Find the LCD of the 2 rational expressions. Consider the denominators which are 3x squared minus 6x and x squared minus 4x plus 4. The factors of the first denominator are 3x and x minus 2. And the factors of the second denominator are x minus 2 and x minus 2. But we need to express repeating factors as powers, so it will become like this. As you can see, there are factors which are common in the list, the x minus 2 squared and x minus 2. But we have to choose x minus 2 squared because this has the highest exponent. We choose also 3x because we will consider all different factors aside from x minus 2. Since one of the factors are in two terms, which is x minus 2 squared, then do not get their product to combine, but instead just write the two factors accordingly, which are 3x and x minus 2 squared, and the LCD is 3x times the quantity of x minus 2 squared. So we now add or subtract the rational expressions with different denominators. For example number 1, if we have negative 3 over 4x plus 5 over x plus 7 over 6x squared, what are we going to do first is to find the LCD of the rational expressions, which is 12x squared, since we get already the LCD of this earlier. And write all the rational expressions with the LCD. So put your LCD here, and 12x squared is divided by the denominator in the first term, which is 4x, and the answer is 3x. Then multiplied by the numerator in the first term as well, which is negative 3. Okay, just follow the pattern. 12x squared divided by x, the answer is 12x, multiplied by the numerator in the second term, and that is 5. 12x squared divided by 6x squared, okay, and the answer is 2, multiplied by the numerator in the third term. Next, multiply, add, or subtract the numerators and retain the denominator. So you are going to simplify them as much as possible. So 3x times negative 3, the answer is negative 9x. 12x times 5, the answer is 60x. And 2 times 7, the answer is 14 over 12x squared. And simplify them further. Negative 9x plus 60x, the answer is 51x plus 14 over 12x squared. If we have 1 over 5 plus 2 over y. So the first thing that we are going to do is to find the LCD of the rational expressions. Since we already get the LCD earlier, and its LCD is 5y, so write all the rational expressions with the LCD. So we write like this, and 5y, which is our LCD, is divided by our denominator in our first term, which is 5. So 5y divided by 5, the answer is 1y, multiplied by the numerator in our first term, which is 1. Another thing, plus, to get the second term, divide 5y by our denominator in the second term. 5y divided by y, the answer is 5. Multiplied by the numerator in our second term, which is 2. And you simplify them further. So 1y times 1, the answer is 1y or y, plus 5 times 2, the answer is 10 over 5y. And this is our final answer. For example number 3. Okay, if we have 5 over x plus 7y over x plus 3, so what we are going to do first is find the LCD of the rational expressions, which is x times the quantity of x plus 3, since we get this one also earlier before this one, and write all the rational expressions with the LCD. So x times x plus 3, divide it by the denominator, which is x, and the answer is x plus 3, multiplied by the numerator in our first term, times 5, plus, okay, x times x plus 3 divided by x plus 3, okay, the answer is x, multiplied by 7y. And simplify them further, you will be getting x plus 3 times 5. So do the distribution process and you will be getting 5x plus 15 plus 7xy. And simplify further, we have 5x plus 15 plus 7xy over x plus 3. This is our final answer, or this must be our final answer. For example, if we have 7 over 3x squared minus 6x minus x squared over x squared minus 4x plus 4, we have to get first the LCD, and its LCD is 3x times x minus 2 squared. Now, in this next process, I transform our denominator into its factored form. So, it will become 7 over 3x times x minus 2 minus x squared over x minus 2 squared. And next one is, I put the LCD here, and this LCD should be divided by our denominator in our first term, which is 3x times x minus 2, and the answer is x minus 2 multiplied by the numerator of our first term, which is 7 minus. Next, to get the second term of our rational expression, so the same thing, we are going to use this one, 3x times x minus 2 squared divided by x minus 2 squared, and the answer is 3x multiplied by the numerator of our second term, which is x squared, and simplify them further. So x times 7, the answer is 7x, negative 2 times 7, the answer is negative 14, or 7x minus 14, minus 3x times x squared, the answer is 3x cubed. If we have 7x minus 14 minus 3x cubed over 3x times the quantity of x minus 2 squared, you can have this arrangement. So we have negative 3x cubed plus 7x minus 14 over 3x times x minus 2 squared. And this is our final answer. Or if you would like to eliminate the parentheses in our denominator, so you can simply multiply x minus 2 by itself and then multiply the product of this to 3x, and you will be getting this answer. So let's proceed on the multiplication and division of rational expression. So here are the steps in multiplying rational expressions. First, factor the numerator and denominator. Second, multiply the numerators. Third, multiply the denominators. And fourth, simplify the rational expressions. For example, if we are going to get the product of these two rational expressions, we are going to follow the steps in multiplying the rational expressions. But if you cannot see the factors of both numerator and denominator of these given rational expressions, you can proceed to the second step, which is multiplying right away the numerator and denominator. For example, 1 times 3 and x times x squared, and the answer is 3 over x cubed. So we are asked to get the product of these two rational expressions. So we are going to investigate the factors of both numerators and denominators. So let us try the factors x squared plus 4x minus 5. So in this kind of example, this is a quadratic trinomial. According to quadratic trinomial, we are going to focus or consider the constant, which is negative 5. Now find the factors of negative 5. The factors of negative 5 would be 5 and negative 1 and negative 5 and 1. And once you add them, the answer is 4. and the answer is negative 4. So as you can see, the second term of x squared plus 4x minus 5 is positive 4. So which factors does comply the rule for getting the factors of this quadratic trinomial? Okay, this one, 5 and negative 1. So meaning to say, our factors would be x plus 5 and x minus 1. Now, let us have this one also. Factors of 3x minus 3. So, 3 is the first factor of these two terms. Why? Because 3 can be seen for both first term and second term. Now, how are we going to get the other factor? So, to get the second factor or the other factor, so we are going to divide our given 3x minus 3 to the first factor, which is 3. So that is why we have 3x minus 3 divided by 3. And the answer is x minus 1 is the second factor. So we have 3 times x minus 1 as the factors of 3x minus 3. So those factors that we have should be placed here and multiply 2x minus 1 over x plus 5. You might be asking me, sir, why we don't get the factors of 2x minus 1 and x plus 5? Because these factors or these polynomials don't have common factors of the two terms. So we just copied them. Okay, so the next one is to multiply our numerators and denominators by having this kind of form. But before we are going to multiply that, see to it that we have observed the factors of both numerator and denominator. So as you can see, we have x plus 5 in our numerator. We also have x plus 5 in our denominator, so we cancel them out. So we have also x minus 1 in our numerator and x minus 1 also here in our denominator. So meaning to say, write the remaining factors, which are 2x minus 1 over 3. And our final answer would be 2x minus 1 over 3. So this time, let's proceed on the dividing of rational expressions. And here are the steps in dividing them. So first, rewrite as the first rational expression multiplied by the reciprocal of the second. After which, proceed to the steps in multiplying rational expressions, which are factors the numerators and denominators, multiply the numerators, multiply the denominators, and simplify, as you will get the simplest form. Okay, for example number 1, if we have 1 over x divided by 3 over x squared. Now rewrite the first rational expression and transform this division to multiplication process. Then the second rational expression should be reciprocated, and it will become x squared over 3. So multiply both numerator and denominators. So we have 1 times x squared over x times 3, and this is the simplified one. But this is not yet the simplest form, so we have x squared over x times 3. You can factor out x squared and it will become x times x, and cancel them out because they are the same, and the answer is x over 3. So if we are going to find the quotient of these two rational expressions, okay, first and foremost, you are going to rewrite the first rational expression and then change the sign of division to multiplication, and then get the reciprocal of the second rational expressions. And then let's investigate if the numerators and denominators have factors. Here, the factors of 2x squared plus x minus 6 are 2x minus 3 and x plus 2. The factors of x squared minus 1 are x minus 1 and x plus 1. The factors of x squared plus 2x plus 1 are x plus 1 and x plus 1. And the factors of x squared minus 4 are x minus 2 and x plus 2. Now, we are going to write all the factors into this form. And then before we multiply them, let's try to consider the factors of both numerator and denominator. As you can see, okay, x plus 2 in our numerator, we have also x plus 2 in our denominator. So we will, we would cancel them out. So we have x plus 1, and the remaining factors are 2x minus 3 times x plus 1 and x minus 1 times x minus 2. So since we cannot cancel them out because we cannot see factors which are the same in both numerator and denominator, so that is why we will be multiplying them using the FOIL method or the distribution process. So the answer would be 2x squared minus x minus 3 over x squared minus 3x plus 2. So this time we will be solving rational equations. In solving rational equations, we have to follow the steps. First is to multiply both sides of the equation by the least common multiple of the denominators. Second, simplify and solve equation accordingly. And the third, verify solution by substituting the value of x to the given rational equation. For example, if we have 3 over x plus 1/2 is equal to 5 over x, to solve this equation, we have to get the value of x. But before that, we will find first the LCD. In finding the LCD, consider the denominators x, 2, and x in the equation. If you still remember how to get the LCD, we are going to factor the denominators to its lowest terms. But x, 2, and x are already in lowest terms. So just get all the different factors with the highest powers. So the LCD is 2x. Now, multiply both sides of the equation by the LCD, which is 2x. Okay, and it can be like this as well. So 2x times 3 over x, 2x times 1/2 equals 5 over x times 2x. Now, let's simplify them further. So 2x times 3, the answer is 6x over x, plus 2x times 1, the answer is 2x over 2, equals 5 times 2x, the answer is 10x over x, and cancel them out because the answer is 6, plus 2x divided by 2, the answer is x, 10x divided by x, the answer is 10. Now this is now the simplified form, but this is not yet our final answer. So we are going to isolate the value of x, or we are going to isolate the variable x by transposing 6 to the other side of the equation. So x is equal to 10 minus 6 and x is equal to 4. To verify that your answer is correct and to verify that your equation is a true mathematical statement, then let's check. So if x is equal to 4, so write the given rational expression. So we have 3 over x plus 1/2 is equal to 5 over x. Now substitute the value of x. So we have 3 over 4 plus 1/2 equals 5 over 4. Now let's get the LCD of the left side of the equation only. So what would be the LCD of 4 and 2? That is 4. 4 should be divided by the denominator in our first term. So 4 divided by 4, the answer is 1. And then copy 3. Plus, okay, divide 4 by 2, which is the second term, or the denominator in our second term, and the answer is 2, times the numerator in our second term, which is 1, equals 5 over 4. And let's simplify them further. 1 times 3, the answer is 3. plus 2 times 1, the answer is 2. So 3 plus 2, the answer is 5 over 4 equals 5 over 4. Solve this rational equation by finding the value of x. In this example, we can rewrite the equation and get the factors of x squared minus 4, which are x minus 2 and x plus 2. Now, we will find the LCD. Again, in finding the LCD class, consider the denominators x plus 2, x minus 2, and these factors x minus 2 and x plus 2. So the denominators are already in the lowest terms. So just get all the different factors with the highest powers. And the LCD is x minus 2 times x plus 2. So we can rewrite this equation and multiply both sides of the equation by x minus 2 and x plus 2. Okay, after which it can be written in this form. So please be guided on this. So simplify them further by canceling out x plus 2 to our LCD and the denominator here. So x plus 2 divided by x plus 2. We have x minus 2 divided by x minus 2. We have also x minus 2 and x plus 2 divided by x minus 2. So we will be canceling them out. So after which the expected answer would be x minus 2 times 4 plus x plus 2 times 5 equals 29. Now we will simplify them further. So this is now our equation. So we will be just simplifying them further. So x minus 2 times 4, the answer is 4x minus 8 plus x plus 2 times 5, the answer is 5x plus 10 equals 29. Now let's arrange the left side of the equation accordingly. So we have 4x plus 5x minus 8 plus 10 equals 29. And combine using the operations, we have 9x plus 2 equals 29. And after which 2 should be transposed to the other side of the equation, and it will become 29 minus 2. Since we are going to isolate the variable x, so we divide 9 both sides of the equation. Okay, and x is equal to 3. This is now our final answer. To verify our answer, let's have this checking. X is equal to 3 and write the given rational equation. So substitute the value of x, which is equal to 3. So we have 4 over 3 plus 2 plus 5 over 3 minus 2 equals 29 over 3 squared minus 4. And we come up 4 over 5 plus 5 over 1 equals 29 over 9 minus 4. Now let's simplify the left side of the equation first by getting the LCD. So the LCD of 5 and 1 is 5. Now divide this LCD to our first rational expression, the denominator of the first rational expression, which is 5. So 5 divided by 5, the answer is 1, multiplied by the numerator of our first rational expression, plus 5 divided by 1, which is the denominator of our second rational expression. The answer is 5 times the numerator of our second rational expression, which is 5, equals 29 over 5. And simplify them further, we can get 4 plus 25 over 5 equals 29 over 5. And 29 over 5 is equal to 29 over 5. That makes our mathematical statement a true statement.